I'm Melissa. I am a flight director for the International Space Station. I communicate with the astronauts daily to make sure the mission on the space station goes smoothly. I don't get to travel into space, but I do get to see the awesome pictures and videos of space that are taken from the space station. Click on the hotspots to learn more. Then click Next when you are ready to continue your journey with the Earth, Moon, and Sun. Do astronauts always see a full moon? No, only part of the moon is lit by the sun. Depending on where the moon and Earth are in relation to the sun, we see different parts of the moon lit. The International Space Station revolves around Earth. It isn't the only thing moving in space. Earth moves too. Earth is constantly rotating. Because of these movements, every time the astronauts look out the windows of the space station, they have a different view of Earth. Check out this incredible video of a sunrise in space. The sun is at the center of our solar system. Earth and the other planets all travel around it. Welcome to the lesson, How do the Sun, Earth, and Moon interact? In this lesson, you'll learn about the motion of Earth and its moon. You'll also find out how Earth's motion causes changes in night and day, and in the seasons. The vocabulary words for this lesson are rotate, orbit, axis, and constellation. Click each word to find out more about it.
Okay, make sure you are writing these vocabulary words in your notebook because we will be having a vocabulary quiz over all of the words in this unit in a couple of weeks.
Rotate. To spin on an axis. Orbit. The path of one object in space around another object. Axis. The imaginary line around which Earth spins as it rotates. Constellation. A pattern of stars that form an imaginary picture or design in the sky.
At takeoff, a commercial jet is traveling at about 275 kilometers per hour. That's fast. So can you imagine how it must feel to travel at 107,200 kilometers per hour? You're doing it right now. This is how fast Earth orbits the Sun. In this lesson, you'll learn how Earth spins and moves around the Sun, and how this motion relates to night and day, and to the changing seasons. The Sun, Earth, and Moon form a system in space. Each part of the system, the Sun, Earth, and the Moon, has its own unique characteristics. Click each part of the picture to learn more about the Sun, the Moon, and Earth. The Sun's diameter is more than 100 times as large as Earth's diameter. As Earth and the other planets move around the Sun and the planets have a gravitational attraction for each other. The force of gravity keeps Earth and the other planets in motion around the Sun. Earth is much smaller than the Sun. Earth's atmosphere protects Earth's surface from the Sun's ultraviolet rays. The atmosphere also keeps Earth at a temperature that is suitable for life. Earth is the only known planet with liquid water on its surface, which is very important. All living things are made mostly of water. The moon's diameter is about 1/4 the size of Earth's diameter. It takes about a month for the moon to move around Earth. Because the moon is moving around Earth, the moon looks different during different times of the month. The sun, Earth, and moon form a system because the moon revolves around Earth and Earth revolves around the sun. The Sun-Earth-Moon system is part of the larger solar system, which includes the other planets and bodies that revolve around the sun. Click on each dot on the line to learn more about the motions of Earth and the moon around the sun. In this first image, we see only the sun. The force of gravity between Earth and the sun and the tendency of moving objects to remain in constant motion keep Earth in its orbit. It takes 1 year for Earth to revolve around or orbit the sun. Now we can see Earth's orbit around the sun. Picture an imaginary line going straight through Earth from the North Pole to the South Pole. That line is Earth's axis. Earth rotates or turns around its axis once each day. Notice that Earth's axis is not straight up and down compared to Earth's orbital path. Instead, Earth's axis is tilted slightly. This tilt is what causes seasons. While Earth revolves around the sun, the moon revolves around Earth. It takes about 1 month for the moon to travel all the way around Earth. During that time, the same side of the moon is always facing Earth. Now that you've learned about the Sun-Earth-Moon system, see if you can describe the interactions between the sun, Earth, and moon. Drag each label to the correct image. Now that you've learned about the Sun-Earth-Moon system, see if you can describe the interactions between the sun, Earth, and moon. Drag each label to the correct image.
Okay, the moon orbits around Earth. The Earth rotates on its axis while it revolves around the sun. And the sun's gravity holds all the planets in their orbit.
Great job! The moon revolves around, or orbits, Earth. Earth rotates on its axis while it orbits the sun. The force of gravity between the sun and the planets holds Earth and the other planets in orbit. Earth turns all the way around on its axis once every 24 hours. It is this turning that causes day and night. When your location on Earth faces away from the sun, it is nighttime. As your location on Earth turns toward the sun appears to rise. It then becomes daytime. As you know, Earth moves in another way while it turns on its axis. Earth also revolves around the sun, which takes about 1 year. During this time, the tilt of Earth's axis causes parts of Earth to receive different amounts of energy from sunlight. Areas that receive more direct sunlight are experiencing summer. Click the play button to learn more about the seasons. At this point in Earth's orbit, the northern hemisphere, the northern half of Earth, is tilted toward the sun. This area of Earth receives more direct sunlight than the southern hemisphere, which is tilted away from the sun. So, it is summer in the northern hemisphere.
Okay, so make sure here we're looking at the way that the Earth is tilted. Okay, so we're starting off looking at the way the Earth is tilted. Okay, this whole thing, all seasons are affected by the tilt of the Earth. It's going to be really, really, really important.
Now Earth has traveled about a quarter of the way around the sun. The northern hemisphere begins to be tilted away from the sun, and fall arrives. About halfway through Earth's orbit, the northern hemisphere is tilted away from the sun. This area of Earth receives less direct sunlight than the southern hemisphere at this point. So, it is winter in the northern hemisphere. At this point in Earth's orbit, the northern hemisphere starts to be tilted toward the sun again, and Earth begins to receive more direct sunlight. So, it is spring in the northern hemisphere.
All right, so again, the tilt of the Earth is what causes the seasons. We're going to learn more about that in this unit.
Which choice best describes what causes day and night? Click your answer.
All right, what causes day and night? The moon's orbit around the sun.
That's not right. The moon orbits Earth in approximately 1 month, causing the phases of the moon. Try again.
Okay, so the moon's orbit around Earth is what causes the phases of the moon, not what causes day and night.
That's not the one. The seasons change as Earth orbits the sun. Try again. Good job. As Earth revolves on its axis, your location on Earth moves from day to night. Earth also revolves around the sun each year, and the tilt of Earth's axis causes the seasons to change. The moon can be seen at night, but that doesn't make it nighttime on Earth. When you look up at the sky at night, you probably recognize the Big Dipper. Throughout history, people have made up groups of stars called constellations and used them to make maps of the night sky. The Big Dipper is part of Ursa Major. Ursa Major appears to move through the northern hemisphere sky all year. Click to learn more. Orion is visible all year from the northern hemisphere. However, it is easiest to find during winter. The middle star appears blurry. But if you look at Orion with a telescope, you might notice that this star is really a cluster of stars within a nebula. A nebula is a cloudy place in space made up of dust, hydrogen, helium, and other gases. Stars are born in nebulas. Many constellations are named after great heroes and people in myths. This constellation is called Gemini, or the twins. To the ancient Greek, this group of stars resembled stick figures of 2 people, sons of the Greek god Zeus. This constellation is best viewed from the northern hemisphere in February. Here we see the constellation Auriga, or the Charioteer. This constellation is most visible in December. Here we see Perseus, another son of Zeus. This constellation is best seen in December in the northern hemisphere. Taurus appears to move from the eastern horizon in September to the western sky in April. In fact, it is visible from the northern hemisphere throughout the year. Today, astronomers know a lot about the movement of Earth and other bodies in our solar system. 600 years ago, however, people had different ideas. The invention of telescopes helped astronomers learn more about Earth's motion in space. Click the image at the top to begin learning more about how ancient astronomers and modern scientists study Earth and space. People have studied the stars for thousands of years. Early astronomers thought Earth was motionless. because they saw the sun, stars, and other planets rising and setting across Earth's sky. Early astronomers thought these bodies revolved around Earth. Early astronomers did not have telescopes. Instead, they used tools like this one to measure angles. Early astronomers used this data to estimate how far away each star was. They also made maps of the constellations. Early travelers used the stars and constellations to help them navigate during their journeys. The invention of the telescope in the early 1600s changed the way people studied stars. Using the telescope, astronomers learned that there were moons revolving around other planets. This discovery and more detailed observations of shadows on the moon gave astronomers further evidence that Earth revolves around the sun. Modern telescopes can be enormous. Using modern telescopes, astronomers can see much farther into space and take much more detailed measurements. The telescope shown here is one of two 10-meter telescopes at the W.M. Keck Observatory in Hawaii. The Mars rover shown here has allowed us to collect information about the surface of Mars. Modern telescopes and technologies such as the Mars rover have helped us understand more about the origins of Earth and our solar system. Early astronomers believed that Earth did not move. They thought Earth was the center of the universe. In this model, the sun, moon, and planets revolved around Earth. Today, astronomers know that Earth and the other planets revolve around the sun. What information helped early astronomers change their model? Write your answer in the box. Click OK when you're done. The invention of the telescope allowed astronomers to make more detailed observations about Earth's moon. Early astronomers also discovered that other planets, including Jupiter, had moons. These and other observations helped early astronomers explain the sun-centered model of the solar system. Look at these images carefully. The seasons change as Earth moves around the sun. Where in Earth's orbit is it summer in the northern hemisphere? Click the correct image.
Okay, so remember we're talking about the northern hemisphere, which is what is at the top of Earth. And this is the northern hemisphere. Remember we're talking about the tilt of the Earth towards the sun is what causes the seasons. So, is it summer when the axis is tilted neither toward nor away? So this is saying that the axis is in the middle.
It's not quite summer yet. Here, the northern hemisphere is just beginning to be tilted toward the sun. People in the northern hemisphere are experiencing spring. Try again.
Okay, again, axis tilted neither toward nor away, but notice it's at a different location in where it revolves around the sun.
Look again. At this time of the year, the northern hemisphere is getting very little direct sunlight because it is tilted away from the sun. It's winter time. Try again.
Okay, so the axis is tilted neither toward nor away, but notice it's moved here in its rotation around the sun.
Not this one. Here, the northern hemisphere is beginning to be tilted away from the sun. It is fall in the northern hemisphere. Try again.
Okay, so in looking at this picture, we're looking for what is different here. Well, first we see the position of the Earth from the sun is it's to the sun's left side. And the northern hemisphere, that's this top part, is tilted toward the sun.
That's right. At this point in Earth's orbit, the northern hemisphere is tilted toward the sun and is receiving the most direct sunlight. This is when the Northern Hemisphere is experiencing summer. Constellations change position across the night sky as Earth moves around the Sun. Sort the constellations according to when they are best viewed. You may not be familiar with them all, but you will be once they are sorted.
Okay, Orion is seen in the summer. Gemini is not seen in summer. Taurus is seen in summer. Auriga, not seen in summer. Ursa Major, seen in the summer. Perseus.
Good job! Although Ursa Major, Taurus, and Orion are best viewed during winter months, they are visible throughout the year from the Northern Hemisphere. Gemini, Auriga, and Perseus can be seen only in winter in the Northern Hemisphere. As Earth moves through its orbit, your location faces different parts of space. So constellations seem to move across the night sky throughout the year. You've learned a lot about the interactions between the Sun, Earth, and the Moon. Let's review the main ideas from the lesson. The Sun, Earth, and Moon form a system within the solar system. About once each month, the Moon revolves, or orbits, around Earth. Earth revolves around the Sun in 1 year. The rotation of Earth on its axis causes night and day. As Earth travels around the Sun, the tilt of its axis causes the seasons. The area that is tilted toward the Sun receives the most direct sunlight and experiences summer. Different constellations are visible in the night sky at different times of the year. Which constellations are visible also depends on where you are located on Earth. Today, we know that the planets revolve around the Sun. The invention of the telescope helped provide evidence that Earth was not the center of the universe. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right, guys, there is a comprehension check for this lesson. Remember, you can go back and watch the lesson again before you take the comprehension check. And if you do not make a 70 on your first try on the comprehension check, you probably should come back and rewatch the video before you do your retake. Have a good afternoon.